So these 2 weeks we're going to discuss atmospheric circulations. So we're moving away from all the different individual variables in the atmosphere. We're kind of combining them to see how the air moves. We've learned how wind is developed. We've learned how pressure changes. We've learned how temperature and pressure are related. So now we're going to put it all together in a way and look at, oh, okay, what does that mean for the weather? So here is a global circulation. The Earth rotates. We know the most heating occurs at the equator and is distributed between the Tropic of Capricorn and the Tropic of Cancer. We get the most heating in that area. So that's where the most lift is going to occur with storms. And then we know the Earth rotates, so that kind of confuses things. So what you wind up with, because of the Earth's rotation, you don't have just one, hottest there right along the equator, so the air is going to rise, come down at the pole, too simple. Well, it's not. So we have a Hadley cell here. The air does rise over the equator. And this is going to rotate to the north in our summertime, to the south in our wintertime. So what that means is along the equator, there's convergence. There's going to be lower pressure. Air is going to rise. Bad weather. Right here around 30 north, notice that the Hadley cell sinks, the Ferrel cell sinks there. Well, if you have air sinking, you're pressing down. We have tendency towards high pressure. Further north, up around 60 degrees, what do you get? Oh, the air goes up again with the polar cell there, so you wind up with lower pressure in that area. And finally, near the poles, tends to be a little higher pressure. So they're the general circulation. Broad ones, very broad. If you were to look at a weather map and looked around, you would see literally more storms around 60 degrees north or that area. High pressure around 30 degrees north. Then you have the intertropical convergence zones fluctuating around the equator. So you're getting it all right there. General picture. General. So with that, we know that the intertropical convergence zone down in the equator is going to move. It's going to follow the sun. So in January, here it is sitting, just along the equator there, low pressure, fluctuating nice and along there. Lows up north, instead of being at 60, maybe they're down around 50 degrees north. That's why we get a lot more storms in our wintertime. Big high pressure, Bermuda high sitting out over the Atlantic, and another one down over Pacific high in the Pacific here. And with that, have a lot of west to east winds across the U.S. Very typical. Summertime. Notice the intertropical convergence zones over water. It doesn't move a whole lot. It moves some, but not a lot. But look at it over land. It was literally down in the southern part of the Indian Ocean in our January. In July, it's up over. What happens is land surfaces heat a lot better than the ocean does. We know that. The ocean takes a while to warm up and a while to cool off. So with that, the intertropical convergence moves north. Well, what happens then? Well, all of a sudden, the flow that was converging down here in the Indian Ocean or south of it is now converging up over Mongolia, Nepal, whatever, up in the mountains there, northern India. What happens if that bird is converging? We have southerly flow coming into there. You have southerly flow coming into that area, all kind of moisture to its south. That's when the rainy season sets in. We get what we call a monsoon. Literally, air continually blowing in from that one direction is a monsoon for a season at a time. Interestingly, we have a monsoon in North America called the North American monsoon. Notice right here, there's a thermal low that develops over the desert southwest. Well, golly, there's a lot of heat there. Plenty of sunshine. Yeah, it's a nice, hot center, we know air rises. Air gets pushed apart when it's heated as well, so the low pressure there. So what happens is air is pulled into that low pressure from the Gulf of Mexico and from the southern Pacific, tropical Pacific. And what happens with that? Bring in moisture to areas like Arizona, New Mexico, Mexico itself. So those are the areas that get, in the summertime, wind up with a monsoon. Generally, the flow is west to east across the jet stream, the westerlies where we live and stuff, and the opposite down in the tropics. However, the jet stream is going to come further south in the winter. Remember, the sun's pushed south, everything moves south a little bit, and further north in the summer. So with that, tropopause. Think about it, tropics. All year long, they're hot. So the tropopause, the air is spread apart, going to be higher. However, between the tropopause, the tropics, and the North Pole, where it's very cold all the time, is going to be an area that tropopause fluctuates. It's going to go up and down depending on the polar front. When you get north, consistently north of it, tropopause is going to be lower. All because of the temperature of the air, spreading it out. So, all right, one last thing I wanted to show you from the book here. Extratropical cyclones a little bit, where they're going to form up to the north and move across. And air masses are part of that. We're going to look at that in more detail here in a minute. But here's a front. And we got this little tiny equation here. Cold fronts are much steeper than warm fronts. So angle is going to be bigger. It's going to go closer to 30, 40, 50 degree angle here. So if you're flying along, say you're flying at 10,000 feet, well, notice you're not hitting the cold front till back up in here somewhere. And so if you were to try to land right in here, though, you would be crossing the cold front and moving into the cold air as you're coming down. Now, if you go the other direction with a warm front, slopes much gentler, you can stay in that warm air mass a lot longer before you finally have to drop down into the cold air mass, maybe to land. So there is some significant differences on how the upper atmosphere is sloped. And you need to understand that so you'll have an idea of whether you're, I definitely can beat that cold front to this air location or whatever. Maybe not. Maybe the cold front's already there at the surface. Yes, you won't be hitting it aloft, but it might be there at the surface. So I wanted to take you now, and hopefully we can bring this up here. All right. We're going to talk a little bit about global circulations again in terms of cyclones, extratropical cyclones, and tropical cyclones. This past week, Helene came ashore as a tropical cyclone. So when it did that, it had a warm core. In other words, the center of the storm was warmer all around, literally, than most of the other areas. There wasn't much temperature contrast there. It was just a warm upwards through. We know that warm core systems, because the air is spread apart, less dense, the pressure is going to fall slower. So actually what happens in the middle of a hurricane is you wind up with high pressure aloft. So as that storm came inland, what happened? Why didn't it stay a hurricane? Why didn't it just not change? Well, the central part of the country is under a much cooler air mass. Matter of fact, the upper air is quite cool. So what happened is that storm got grabbed by that cold air and gradually became colder itself. So instead of having no temperature contrast, nice warm environment, It developed a temperature contrast, and it is now being powered by that temperature contrast. Tropical systems are powered by moisture, latent heating, all kind of heat related to plenty of tropics. Extratropical storms are powered by the temperature difference. The more the temperature difference, the stronger the storm can become. That's why along the east coast of the United States, we have a Gulf Stream that sits out there. In the wintertime, you can have these Arctic air masses come down from Canada. They hit the coast, hit that Gulf Stream, and one side of that front may have temperatures in the 30s, low 30s. The other side might have temperatures in the 70s or even close to 80. That's a 40 to 50 degree temperature contrast. That is an extreme temperature contrast that makes for the potential for extreme storms. That's why we get these nor'easters. I also wanted to show you on satellite how, notice this one's all wrapped up. This is what's left of Helene. Here is another storm they look like commas. The more they look like a comma, the more intense the storm probably is, and it's getting towards where it's most mature. Storms, extratropical storms, will begin with almost like a wave pattern, looking like more like this actually, even though this is towards the end of its life cycle. But then they become more of a comma shape. Sometimes see these across the whole globe. You'll see one following after the other. Now, here is notice there's no fronts, nothing around it, just a bunch of thunderstorms sitting in tropics. Here is our current 500 millibar map. Actually 300, excuse me. So we have our jet stream well to the north, right? And here's a jet streak. A jet streak is just a stronger wind blowing in the jet stream. These are what trigger extratropical cyclones. Well, why would they trigger them? All right, along this very strong wind max, towards the front of it is divergence, right in here. On the left-hand side of the front, right-hand side of the front, convergence. Back behind it, divergence, convergence. Oh, I have divergence aloft here. What happens if I have divergence aloft? Air has got to rise to take its place. So we wind up with lower pressure at the surface. This is how extratropical low pressures form with these jet streaks. They are what initiate them. That combined with the temperature contrast, they initiate it along the front typically, because the biggest temperature contrast are going to be along these jet streaks. Now, what's going on in the middle section? This area of low pressure, and it's cool, literally is a cutoff trough. We have the jet streak along to the north, coming out over here. It's not in normal flow, so eventually it's just slowly being moved towards the east. We have high pressure down here. Eventually this will move out, and flow will begin to come back into here, and it will change. But right now, that's what's holding what's left of Helene right in the middle part of the country, and it's not moving very much. We can actually look back at the surface of all this and say, hey, maybe I can get this one to come up. Nope. But go north. We can get up to, remember I said there was a jet streak up here and low pressure might be forming? Well, there it is up to the north here. And these lows are right along a front. So here's a cold front. I wanted to tell you also what's the front. So on the north side in the northern hemisphere, it's going to be colder air probably. On the south side, it's going to be warmer air. Most air masses form under high pressure systems that sit literally over some part of the globe. So think about it. If we have a high pressure over Canada, what's up there? Well, in the wintertime, it's snow covered, dry. Oh, it's very cold and dry. Oh, that's going to be a continental polar air mass. Now, if I formed an air mass over the southeast Atlantic What would that be? Pretty much moist ocean, kind of warm. Temperatures of ocean are probably in the 70s, at least upper 60s. So it's a maritime tropical air mass. Now, if I formed one over the desert southwest, that would be a continental tropical air mass because it's hot and dry. So where these air masses come together is the fronts. Along that front is where weather is going to occur, and where the low pressures are is pushing these fronts along. You're going to have strong waters. If there's a strong cold front, there's probably a strong low pressure associated with it, and a strong warm front, probably coming out from the low. So hope you got a little bit out of all this, because as you're flying around, you're going to go through these features. And you need to understand that when you see these on a weather map, or somebody tells you you're flying into an area that cold front may be passing through or warm fronts, you need to understand the broad picture that, oh, I've got a cold front. Well, I'm probably going to have some steeper push up to the air. Showers may be a little more intense. Oh, I got a warm front. Well, I'm going to have a long area of clouds, maybe a long area of low clouds. So I may have more IFR. So hope you got a little bit out of this, and let me know if you have any questions.